Okay, suppose the distribution of serum cholesterol values in undergraduate men is approximately normally distributed with a mean of 190 milligrams per deciliter with a standard deviation of 40 milligrams per deciliter. So the first thing we do is we state the problem. And our problem is, what is the probability of finding a person that has a cholesterol less than 180? There you go. That is our problem. Now we need to standardize that. Now here is where I made a mistake. This is incorrect, and I apologize for that. What this should say is, this is actually relating to part C, and as well as finding the sample distribution of the means. This is just our regular Z. So I'm actually going to put an X here, which is going to be this 180. And then rather than the standard error, it's actually going to be just a regular standard deviation. I need to get rid of that hat. There we go. Okay. So this is the correct way. And I apologize. That is completely my mistake. I missed that. So if we were to standardize our Z-score now, what does that look like? Well, we do an equals, open parentheses. It's going to be 180 minus 190, close parentheses, and then our standard deviation divided by 40, and we get negative 0.25. So that is our z-score. So if we were to actually draw something like that, here's our z-score of 0, and then we have negative 1, negative 2, let's say negative 3. So negative 1, negative 2, negative 3. All right, so we looked this up visually. What this would look like is about right here, maybe. Whoop. And this is what we were looking for. So what is the probability of finding someone that has a cholesterol of less than 180? Just one person, okay? And that is going to be, when we look up in the back of the book, we do table B. So this first, the question marks are going to be negative 0.25. And when we look it up in the back of the book, we have 0.4013. So what is this saying? That is saying that this little p-value right here is at 0.4013. Now we conclude, and to fill in the question, or fill in the blanks, it is the probability of selecting a man from this population with a cholesterol of 180 milligrams, that should say, excuse me, yeah, that is correct, or less, is going to be 40%. Just 40% right there. So that's where we're getting this 40%. What if we were just to put our hand in the bag and pull someone out, and the chances of them having a cholesterol less than 180 is 40%. Let's move over to, you take a simple random sample of N, or equals 49. So 49 individuals from this population, and calculate the mean cholesterol of this sample. Describe the sampling distribution of the mean. So remember, what's different about the sampling distribution of the mean is when we were to go up here, so if this is a normal Z bell curve, like we're looking at something that's like much more narrower, like this. All right, so that, again, that's what the sampling distribution of the mean is. And I already put it in right here. And so let's just fill it in real quick. It's just going to be equals 40 divided by the square root. So how do we do square root? We type in S, Q, and then you see it right there, RT, open parentheses, 49, close parentheses, and we get 5.714. That's it. That's all we do for B. Now let's do part C. Regarding the mean derived from a sample mean of N49, what is the probability of getting a sample mean that is less than 180? So let's just look at this visual here again. What we have, can I delete that? Yes. Okay. So if this is like the normal population, but we're saying that if we have an N of 49, so an N of 49, what are the chances of actually getting like a normally distributed group of people that has something that is within this shaded area? So rather than just one, we're talking about an average that is going to be less than 180. So let's go ahead and figure that out. So this is where we are looking at the sampling mean. So we start off by standardizing our z. So I'll put in a z equals, and I'll make sure that that is flushed. Okay, so our z equals, and it's just like last time. So again, we are looking at anything less than 180 minus 190. Oh, we almost forgot the parentheses. So we'll come up here. 180 minus 190 divided by, and now rather than a standard deviation, we are using our sampling distribution of the mean. So I'm going to click that right there. And we get 1.75. So if we were to look that in the back of the book, negative 1.75 is going to be 0.0401. So we're basically saying within this z value, if we were to go back up here and we are looking at like a negative 1.75, it's going to be like right here. We are asking, what is the probability of getting like another standard normal distribution at this level that is completely to the left of this 180? Remember, because this right here is 190, and it was a 40% chance of getting something, just one person at less than or equal to 180. But now we're talking about 49 people trying to get an average that is less than 180. So this is just a vague, area that I'm drawing here. And the chances of that, the probability of finding a mean this low or lower is 4%.